where he describes ultimate reality, quantum reality, as being an effervescent, bubbling, violently frothing reality. We also read Brian Greene, the famous string theorist. He said the exact same thing. There are tons of other examples I could have given, but we just didn't have time to do. So that's quite amazing. Also, so I'm interpreting a little bit here when I say that the sea foam is white. Well, I mean, I'm not interpreting that sea foam is white and brilliant like light. But I take that to be also significant because nirvana is endlessly considered to be some sort of endless, infinite light or infinitely powerful fire that is everything. Now it's right here, and I didn't assign you the introduction to this, the Dhammapada. It's not, in my opinion, it's not the greatest introduction. It's not very philosophical. But I mean, right here on page 11 of this introduction, there is a reference to that. I mean, I could bring up several others from Dreyfus and other things we've read, but right here it's talking about how the Buddha woke up into infinite light, which is, you know, that's just simply, it's being used in here as synonymous with nirvana. So, yeah, and also foaming. That's unbelievable too that that's being used because, well, the last class we're talking about this thing called quantum foam that was in the notes, and I didn't really explain it very much, and I'm not going too much here, but that's something that's been used for decades by quantum physicists to describe the patterns in ultimate quantum reality, but also cosmic reality, the big picture, galaxies and so forth. You know, where if you look at, there's going to be patterns in the chaos. You know, it might look something like this. You know, if you look at the quantum level, the quantum chaos center is just going to, you know, form sort of concentration areas, and then, you know, things that are more like voids of activity, of what the measurable quantum particle activity. So it ends up looking kind of foamy, like a bubbly reality. And then also, you look at the big picture of the cosmic scale of galaxies. They form galaxies. You know, stars are found in galaxies, sort of these pods or islands, collections of stars. And then the galaxies themselves, the galaxies, they can be huge. You know, ours, for example, the observable part of it is 100,000 light years across. That's how far light goes in 100,000 years. And then, but there is apparently what's called dark matter, which I'm a little nervous talking about that because dark matter is something that's not necessarily been directly observed. Its effects are seen. Nobody really knows what it is, as far as I know, yet. It's theorized some sort of invisible particle that has a gravitational effect. But there's a dark matter component of the galaxy that goes much, much further, that perhaps makes our galaxy. So if you have a visible part of our galaxy, let me just draw it as a big disk like this, like that. So if we're looking at it sort of on its side, or sorry, as if it's laying flat, and then here's the, you know, the top of it pointing that way. So it's sort of like a disk. So this part of the galaxy would be 100,000 light years across, but the observable part of the galaxy, or sorry, the invisible part of the galaxy may go way out to something like over here, just not be seen. Maybe you can measure this with non-visible light telescopes, like a radio telescope. Something that measures different light waves that are not visible light. Yeah.
Is dark matter the same thing as antimatter?
No, antimatter is that's a very surreal topic. Every piece of matter, every quantum particle. Physicists call quantum particles matter still. As you can see from the meteorological analysis paper, I reject that, call it non-matter for really good reasons. It has nothing to do with, you know, looking like this anyway. But anyway, so let's just use the phrase antimatter since it's out there. But you know I'm talking about quantum particles. So antimatter, something strange happens when we look at quantum particles. We find out any particle has a twin, you know, which has all the opposite traits, you know, somewhere, you know, right around it or something, and they don't touch. If they did, So now there's lots of theories as to what exactly is going on with this, why particles exist in these pairs and so forth. Do they exist in this? There's a lot of theorization going around that they don't exactly exist in the same dimension. So our universe is made up of two dimensions, the matter dimension and the antimatter dimension. Now this might sound weird, this is quite mainstream physics. So that's that. Okay, so there's going to be a parallel Jeff, antimatter Jeff, sitting in the other universe, doing the exact same stuff as you, basically. Now that's not the same as a part.
Just like backwards.
Yeah. I mean, no. Sorry. No, it will be all the same. It'll just be all the charges of the part. It's indistinguishable from this universe. It's backwards in the sense that all the particles have reversed charges and so forth, but the net effect is you've got the same and indistinguishable universe. Now, so in a sense it's a parallel universe, but parallel universe is not the same phrase used either. So the antimatter is usually not considered another universe. It's usually considered a different dimension of our universe. Whereas, so we're talking in terms of universes here. So we're talking in terms of physicists. So just let that go. Parallel universes are whole other universes that can be similar or very similar to our universe or very different, and they could overlap ours, coincide with ours, just we don't see them, or they could exist far, 60 trillion light years to that way or something, for example. No, but dark matter is different even from that. Dark matter is just ordinary particle activity, not antimatter, just ordinary particle, the stuff that we interact with in our, ordinary division 2 consciousness. And it's just, we don't see it, it doesn't interact with light. So it's all around, it's in this room and so forth, but we are virtually oblivious to it. That's very interesting. And most of the matter is theorized to be dark matter, and where light matter is the rare stuff, maybe 1 or 5 or 10% of observable matter is light matter. So that means that the whole universe out there isn't seen by us. And something interesting, if quantum particles have the property of, or have the effect of creating patterns of activity that observers can pick up on, as we've been talking about in this class, and where the observers out of that quantum activity can create ideas of what a world is all about. So this book right here is, it looks like a solid book and so forth, but really it's just the activity of quantum particles. Now, the idea would be that if that's what particles do, and if dark matter is made of particles, then there's a whole dark matter galaxy and universe coinciding with us right now that we don't see. So that's pretty. There could be dark matter planets or suns or something right here in our own galaxy that we're just oblivious to. Now, that's the theory. I don't know if I buy it or not. I'm suspicious of the whole dark matter thing, personally. But that's just me. So anyway, yeah, good question. So yeah, the foaminess, quantum foam is a phrase that's been used by physicists following a physicist named Roger Penrose, to just describe the soapiness or foaminess of reality. And then here you have the Buddha talking in terms of bubbles and soap and foam and frothing and all this stuff, all over his book, the Buddhapada. So that's pretty interesting. I think it's more than interesting personally. But, okay, so let's keep going then. Unless there's any other questions. Yeah?
Okay, this is kind of a stupid question, but so that book was written by
Gotama.
And foamy was invented back then, like the word?
I don't know what the
So like,
Sanskrit
what was this
is,
translated from?
Sanskrit.
Okay. So that's supposed to be word for word?
Yeah, it's supposed to be, translations are always suspect. So yeah, we'll hope that I don't have the original Sanskrit copy.
I just don't understand how like some of those words that would be.
Well, you have to think about it. If you're the translator, knowing the Sanskrit word, what it represents in, India, for example, and to the cultures that were using Sanskrit at the time that this was originally written, hopefully they meant something like frothing or bubbling, It would seem pretty likely that they have a word